Hello, my name is Sam, captain of FTC Team 2845 Team Duct Tape. In the 2025 to 2026 Decode season, I've led my team through the challenging design of a game element sorting robot. In addition to sharing the design innovations of a robot, I'll be highlighting how I coordinate teamwork for effective robot development. From the beginning of the season, we decided to build a robot that uses a spindexer to sort artifacts and score pattern points. We knew that using a spindexer would slow down our cycle times, and that we would need to use advanced control algorithms to make up for this. In order to develop the software and hardware in parallel, we produced handmade prototype test setups for programmers to experiment with, while the mechanical team improved the design by CADing and machining parts with a CNC and laser cutter. Upon going to our first competition, we discovered that drivetrain-based aiming wasn't enough to be accurate when other robots were defending the goal. This prompted me to get the team together and brainstorm new solutions. Together, we came up with a new design that preserved our spindexer while introducing a turret. The new robot was designed such that new control algorithms could build upon existing code, and everyone could move forward with new mechanical and software challenges. I divided the work between task-focused groups: designing the launcher and turret, designing the new spindexer, and writing new launcher algorithms. This is when I taught the team how to use on-shape version control so that we could keep track of iterations and work on alternative designs in parallel on our shared on-shape document. 9 of our 15 team members have contributed to the team design via CAD. One of the biggest challenges was attaching our launcher while minimizing the turret's friction. Our first attempt didn't go so well. We solved this with the help of a mechanical engineering mentor by designing our own custom 3D printed ball bearing, which uses industrial grade aluminum balls for fast and sturdy turret movement. The completion of this design took several iterations. Getting more team members involved in the design and fabrication of the bearing let us complete the task in less than 2 weeks, despite being a mechanism completely new to everyone on the team. While the turret was being built, I joined the programming team in writing our new launcher algorithms. First, we built a regression to map distance from the goal to flywheel velocity. Then, we wrote an autonomous aiming algorithm that uses April tag data to always aim at the back corner of the goal, which we found was the target that provided the most consistency. A big challenge of using Spindexer is that we need our intake to be precise and work cohesively with the Spindexer. To achieve this, we use color and distance sensors that keep track of what Spindexer slots are already full, and only intake while an empty slot is in the intake position. The control algorithms coordinating the Spindexer and intake enabled us to maximize the mechanical speed of our intake. We found that a combination of compliant wheels and vectored wheels running at over 1,000 RPM gave us the fastest and most reliable intake. We knew we had a strong design, so we made sure to leave plenty of time for drivers to practice and take advantage of all our new control features. The coordination of team efforts to quickly complete the design and practice brought us to being the winning alliance at the Florida Robot League Championship. We are very proud of our design and teamwork, and made sure to do an excellent job in documenting each aspect of the robot and our team in our engineering portfolio. This helped each member of the team fully understand each aspect of the robot in depth and convey important information to the judges during our interview. Our teamwork in building a winning robot and strong documentation earned us the first place Inspire Award at the Robot League Championship. For the Florida State Championship, we're focusing on harnessing the new knowledge of each team member who learned through the documentation process to speed up our robot's scoring capabilities. Our Spindexer is a limiting factor in scoring speed, as it determines how quickly the robot can launch and intake. So we're focusing on speeding up the robot by replacing the 2 lone servos on our Spindexer and transfer mechanisms with 2 servos running at 2-to-1 ratios. The team's combined efforts let us complete all mechanical changes in under a week. We expect these changes, combined with more reliable control algorithms, to more than double our intake and launching speed. None of our achievements would have been possible without effective teamwork and coordination. One of the hardest areas in which to collaborate is programming. On top of this, many team members find coding daunting at first. To solve this, I divided our code into 4 categories: subsystems, op modes, commands, and utilities. Subsystems and utilities contain the most advanced software, which are accessed by the commands and op modes. This enables new team members to first learn how the code is structured and used by making commands and autonomous op modes, and then learns the most advanced and fundamental levels of control and hardware interaction. We also used GitLab for version control and collaboration. This season, we have doubled the number of team members contributing to the code. First has shown me that the most powerful design innovation isn't a mechanism. It's a team that feels confident in solving hard problems together. And that's the foundation that I'll continue to build on as I move forward at WPI.